Hey everybody, Matt Cutler from Blocknative. Super excited to share with you the latest on our Gas Network. Gas Network is a decentralized Oracle platform for real-time gas price information. We have come a very long way with it, and it's now ready for real-world developers to go hands-on. I want to give you a walkthrough of both the architecture and show you the oracles themselves using our demo dApp. Now, we're building this because we view this type of capability as absolutely essential for on-chain interop. You have a protocol on chain A. It's trying to transact on chain B. From chain A, you need to know what the current gas market is on chain B, and you just don't know that. There's no way to know. And so today, how everybody does this is off-chain resources, proprietary APIs, RPC endpoints, completely no standardization, and a lot of variability in quality. And so we're building Gas Network to normalize all of that, to make it one-stop shop to get everything you need, put that data on chain, make it as trustless and permissionless and composable as possible to facilitate on-chain interop and improve usability. Now, let me show you how we do that. We're going to just jump into this quick high-level architecture diagram. Now, Gas Network itself is the blue, where we have these gas agents that are making the predictions. They write to a high-speed app chain called GasNet. We then make that information available via distributed oracles. We're going to have oracles on each one of the chains that we support, and the oracles communicate with GasNet via what we call Gas Bridge, which basically allows cross-chain messaging with signatures to ensure that the messages are real and accurate. We also have the separate thing that we call Gas Gauge. That's a reference to our leading gas extension many of you may be using. Basically providing some new gamified opportunities for getting folks in your community to update these oracles on the fly. Now, there is a bunch of really interesting things happening here. These oracles can run in either push or pull orientation. We're going to be operating them in both, at least to start. And as we move forward with the architecture, we'll be introducing things like staking slashing models, shared governance, and in fact, some of this stuff may operate maybe as an actively validated service or even inside TEEs. But this is sort of the architecture we are, and it's all fully functional right now. Now, to get into this, you can just go to gas.network and you can click try the demo. I already have that open here. And what that's going to do is open up this demo dApp. Now, this is both a custom-built dApp that shows how the Oracle works in push and pull format, but it's also somewhat of a preview of this on-chain game that we have coming. Now, I notice a few things here. There's documentation link, obviously. There's two versions of the oracles, and I recommend the V2 oracle. It's much more gas efficient and much more compact. And we support various networks, both testnet and mainnet. So we're going to put on mainnet right now. Now, a couple of things. First off, today our platform supports 36 chains total. You can see all of those here, and we're of course adding to them all the time. So this list will continue to grow. And right now we can write to the following mainnets: Arbitrum 1, Base, Ethereum mainnet, of course, Linea, Optimism, and we recently just added Unichain. So what you can do is you can read estimates for a specific chain and then write it to a specific location. Before I do that, I want to show something which you can read as well. And so on Unichain mainnet, and most of these with the exception of Ethereum mainnet, we're actually operating in push mode. And so what that means is once an hour, Blocknative itself is proactively pushing updates to the Oracle. So I haven't done anything else right now, but if I just want to read the Ethereum for Ethereum mainnet on Unichain with a recency of 1 hour, I can click that, and we're literally reading right off the chain, and we can see that that oracle was last updated 15 minutes ago. So if you're building on Unichain mainnet and you're trying to have, let's say, a Uniswap v4 hook that incorporates real-time gas prices, or you want to experiment with on-chain interop, you can use this oracle. It's there, and you'll have data which is no more than an hour old. Now, these status codes, this is part of it being very compact and gas efficient. If you were to click through into the documentation at the top and look at the Oracle v2 document, you'll see there's a variety of types that we use. 107 is base fee per gas, 112 is blob-based fee per gas, and 322 is max priority fee. We do intend to extend this down the line, and that's obviously quite straightforward to do it in this method. But let's say you're building something which has much more sensitivity to real-time gas price, meaning an estimate which is 16 minutes old isn't going to work or introduces too much risk to your protocol. You can, of course, adjust the time window of recency on the Oracle update. So let's put it at 30 seconds. We're now going to try to read, and we get an error. And the reason why is this Oracle has been updated more than 30 seconds ago, of course. And so it returns an error that your smart contract can ingest and obviously make decisions on. Now, in this situation, you can now pull the Oracle. And what that means is you'll use Gas Bridge to read information off of GasNet that has been generated by a gas agent, and then turn around and write that down to Unichain mainnet. And let's do that right now. So we're going to click here. That's right here is through Gas Bridge. This is the data from the gas agent served off of GasNet. And then we need to write that down. So here is a transaction to do so. I'm going to hit confirm. We're just going to wait for Unichain to confirm that transaction, which is, oh, there it is. Okay, so we're going to read, and there we go. So here's a confirmed transaction with a recency of 30 seconds, and we get a result. That's amazing. Now, if I were to go in and say 10 seconds, again, there's an error because it's now more than 10 seconds old. But if I do 1 minute here and read, I get the same result. So you can see how this architecture basically enables arbitrary information that our gas agents are generating and putting down on GasNet to be read and then written down to an Oracle on an arbitrary destination chain. We think this unlocks a huge range of possibilities surrounding on-chain interop and things like paymasters to improve usability. We're super excited about that. And this, of course, is a test harness, but what we're going to be doing is building this experience sort of into our gas estimator. So our gas estimator today is used very widely. We have more than 50,000 MAUs. It supports a whole bunch of chains. We have a whole bunch of upgrades coming to it soon. You can get that from the Chrome store. And this is all going to be part of this entire experience, where we'll be incentivizing folks to use the extension and a future version of the demo dApp to proactively push updates to our gas oracles. But for right now, what we're looking for is on-chain actors, wallets, protocols, smart contracts, bridges, solvers, bundlers, paymasters, bots, you name it, to go hands-on and to provide feedback. We're also recruiting our initial Genesis collective, the set of projects that want to be part of Gas Network from the outset, participate in governance, and obviously get a bunch of incentives along the way for doing so. So please take a look. Love your feedback. And again, this is Matt Cutler from Blocknative introducing you to Gas Network.